Chapter 1. Introduction to FSPCA Preventive Controls for Human Food course. The objectives of this course include comprehensively understanding the current good manufacturing practice, hazard analysis, and risk-based preventive controls for human food regulation, commonly referred to as the Preventive Controls for Human Food Regulation. Published on September 17, 2015, this regulation is vital for ensuring the safe manufacturing/processing, packing, and holding of food products for human consumption in the United States. In this chapter, we will delve into the format of the course and provide a succinct overview of how preventive controls build on established food safety principles. This foundational understanding will serve as a bedrock for your comprehension of subsequent modules. Furthermore, we will examine the components of a food safety plan and delineate the responsibilities of a Preventive Controls Qualified Individual, PCQI. It's imperative to underscore that a PCQI must possess the necessary expertise to develop and implement a robust food safety system. As emphasized in Chapter 16, Regulation Overview and Appendix 1, a PCQI is required to have successfully completed training in the development and application of risk-based preventive controls at least equivalent to that received under a standardized curriculum recognized as adequate by FDA, or be otherwise qualified through job experience. This course, developed by the Food Safety Preventive Controls Alliance, FSPCA, constitutes the standardized curriculum acknowledged by the FDA. Completion of this course is one of the pathways to becoming a Preventive Controls Qualified Individual. To navigate the intricacies of this course effectively, it's crucial to speak the language of food safety regulations fluently. Therefore, we will provide resources on where to find definitions for terms crucial to understanding the preventive controls for human food regulation. These definitions will elucidate specific terminology used throughout the course, drawing primarily from the regulatory framework itself. By the end of this chapter, you will not only grasp the fundamental objectives and structure of the course but also gain insight into the pivotal role of a PCQI in ensuring the safety and integrity of food products for human consumption. The course is divided into 3 parts. 1. The first part defines the contents of the food safety plan, reviews foundational programs such as GMPs, provides information about specific food hazards, and discusses the underlying principles used in food safety preventive control systems. Learning how to apply these practices and principles will give a better understanding of how a systematic approach can help to assure the safety of food. As each principle is discussed, the class will progressively develop a food safety plan for a model product produced by a fictional company. This example will help you understand how to put together each section of a food safety plan and how these sections relate to a complete preventive controls program and safe food processing. 2. The second part includes practical exercises that introduce the participants to the process of developing a food safety plan, including identification of tools and implementation tasks. 3. The third part explains the requirements of the preventive controls for human food regulation. Remember, throughout the course there are lots of activities you must complete. A proactive and systematic approach to food safety emphasizing the preventive controls approach has been universally accepted and adopted throughout the world because it helps to focus on what matters and puts attention on the most important areas. To prevent food safety issues rather than reacting to problems as they arise, preventive control programs are structured to work in conjunction with and be supported by other relevant programs such as good manufacturing practices, GMPs, good agricultural practices, and good transportation practices as the basis for food safety management. Successful application of preventive controls approaches will not only help to ensure regulatory compliance, but also minimizes the risk of producing products that can harm consumers. Risk-based approaches to managing food safety were pioneered during development of food for the U.S. space program in the 1960s. At that time, in-product testing was the focus of quality control programs. It became evident that the end product testing necessary to provide assurance that the food was safe would be so extensive that little food would be available for space flights. The focus shifted to preventing hazards through product formulation and process control in a risk-based manner. The concept was called hazard analysis and critical control point, HACCP. HACCP implementation expanded voluntarily in the food industry with the understanding that food safety is best assured if each producer and processor understands the significant hazards in their product and operation, and uses scientifically sound preventive controls to significantly minimize or eliminate the hazards. In the 1970s, FDA used HACCP principles in the development of low-acid canned food regulations. The U.S. National Advisory Committee on Microbiological Criteria for Foods, NACF, and the Codex Alimentarius Commission, Codex, published HACCP principles in the 1990s. FDA has HACCP regulations for seafood and juice products, USDA has HACCP regulations for meat and poultry products, and HACCP is endorsed by many countries, including Australia, Canada, New Zealand, and European Union countries. HACCP principles are illustrated in the slide. A quick review of these principles is useful to understand how the preventive controls for human food regulation complements the risk-based HACCP approach. In a HACCP system, hazard analysis identifies process-related hazards that, in the absence of control, present a food safety risk. When these hazards are identified, critical control points, CCPs, that are essential to control the process to prevent the hazard from causing illness or injury are identified. When these CCP process controls are identified, the critical limits define the operating conditions in the process that must be met to effectively manage the hazard. Monitoring of the process is done to provide data to demonstrate that critical limits are met, and corrective actions are predefined to enable swift action when things go wrong, thus preventing expansion of a food safety issue. All of the above is recorded and verified to ensure the system is operating as intended and to provide data to others, e.g., inspectors, auditors, management, new employees, to show that this is the case. More information on each of these principles is discussed in this curriculum, recognizing that a HACCP plan essentially addresses most of the requirements for process preventive controls. Each of these concepts is discussed in greater detail in subsequent chapters. However, the preventive controls process incorporates controls beyond those managed as process-related CCPs in the HACCP framework. These preventive controls address not only CCPs, but also controls for hazards related to food allergens, sanitation, suppliers, and others requiring a preventive control. The preventive controls approach also recognizes that critical limits, defined by NACF as a maximum and/or minimum value to which a biological, chemical, or physical parameter must be controlled at a CCP to prevent, eliminate, or reduce to an acceptable level the occurrence of a food safety hazard may not be required for some preventive controls. The broader term, parameters and values, supports identification of a frequency or other metric to assess compliance, rather than setting a precise minimum or maximum value to which a parameter must be controlled. Further, immediate corrections, like recleaning a line before startup, may be more appropriate than formal corrective action involving product risk evaluations for some preventive controls. Finally, the extent of validation activities, or demonstrating the controls actually work, may be less rigorous for some preventive controls than others. Each of these concepts is discussed in greater detail in subsequent chapters. The extent of validation activities, or demonstrating the controls actually work, may be less rigorous for some preventive controls than others. Each of these concepts is discussed in greater detail in subsequent chapters. The Food Safety Plan is a dynamic document which must be kept current if changes are made to the system or to equipment when new products are added or new hazards are identified. The schematic above illustrates that the Food Safety Plan includes a number of elements. It starts with hazard analysis, which is used to identify required preventive controls for the process, for sanitation, for food allergens and supply chain programs, where these are needed to address the hazards requiring a preventive control. These elements, along with a recall plan, make up the Food Safety Plan. Many GMPs and other prerequisite programs are managed outside of the Food Safety Plan. While these are separate programs and may not require the same level of documentation as the elements of the Food Safety Plan, they are important. They are generally managed using standard operating procedures with documents and records kept as appropriate. Keep in mind that elements of GMPs that are not covered in the Food Safety Plan are still required by regulations. GMPs are required because they form the foundation for your food safety plan. Developing a food safety plan helps you to focus most of your activities on what matters most for food safety. Under the regulation, certain tasks must be performed or overseen by a preventive controls qualified individual. This course developed by FSPCA is the standardized curriculum recognized by FDA. Successfully completing this course is one way to meet the requirements for a preventive controls qualified individual. Under the Preventive Controls for Human Food Regulation, the responsibilities of a preventive controls qualified individual include to perform or oversee 1. Preparation of the food safety plan, 2. Validation of the preventive controls, 3. Records review, and 4. Reanalysis of the food safety plan. The preventive controls qualified individual may be an employee of the facility, but you can also use outside assistance in developing your plan. In some situations, more than one preventive controls qualified individual may be needed to effectively develop and implement a food safety plan. More detail on the different parts of the food safety plan is provided in this course. See the 21 CFR 117.3 definitions for qualified individual and preventive controls qualified individual, as well as the 21 CFR 117.180 requirements applicable to a preventive controls qualified individual in Appendix 1 attached in the chapter Resources. Prevention-based food safety management can be integrated into any operation. However, the process can seem complicated until the basic concepts are understood. Asking questions from others who are PCQIs or reaching out to safefoodtest.com can sometimes be all you need. This course includes class various activities and exercises to help provide a deeper understanding. The more serious you take these exercises, the less complicated the system will seem and the easier it will be to develop and implement an effective food safety plan. We have provided a digital copy of the manual in the chapter Resources. Become familiar with it and use it as a reference. It contains forms that can help you develop a food safety plan and resources to locate other basic information. Make as many copies of the forms as necessary or copy the whole manual to share with others in your company. As you learn more about developing a food safety plan, there are many definitions that you need to understand. To assist you, the definitions of many commonly used terms are listed at the end of the chapter. Refer to these pages as needed. You may also want to add other terms that you may need in developing and implementing your own food safety plan. By successfully completing this course, you will meet the training requirements for a preventive controls qualified individual who can oversee a food safety preventive controls program. You may need assistance from technical experts for certain elements of your food safety program, which will be discussed in chapters later in the course. Through this course you will learn how to develop a risk-based food safety plan and implement preventive controls to help mitigate and control hazards specific for your product and process. This reduces potential food safety issues for the public and for your business as well. Don't forget the importance of speaking the language and spend some time studying the definitions and acronyms at the end of the chapter. Actively participate and everything should go just fine. What's new in a food safety plan? In the FSPCA curriculum for PCQI training, there are several differences highlighted between a food safety plan and a hazard analysis and critical control points (HACCP) plan. Here are some of the key distinctions. Scope. Food Safety Plan. The Food Safety Modernization Act, FSMA, requires covered facilities to have a comprehensive food safety plan that addresses preventive controls for hazards reasonably likely to occur in the food processing environment. HACCP Plan. HACCP plans traditionally focus on critical control points, CCPs, in the production process to prevent hazards that are identified as significant for food safety. Regulatory mandate. Food Safety Plan, mandated by FSMA. The Food Safety Plan encompasses a broader range of preventive controls beyond those covered by traditional HACCP principles. HACCP Plan, originating from the Codex Alimentarius Commission and further developed by various regulatory bodies. HACCP plans primarily address hazards critical to food safety but may not cover all preventive controls required by FSMA. Approach to hazards. Food Safety Plan emphasizes a preventive approach, requiring facilities to identify and implement controls for all reasonably foreseeable hazards in the food production process, including biological, chemical, physical, and radiological hazards. HACCP Plan focuses on critical control points, CCPs, for hazards identified as significant to food safety, typically limited to biological, chemical, and physical hazards directly related to the processing steps. Documentation requirements. Food Safety Plan requires detailed documentation of the entire food safety system, including hazard analysis, preventive controls, monitoring procedures, corrective actions, verification activities, and record keeping. HACCP Plan also necessitates thorough documentation, particularly regarding hazard analysis, identification of critical control points, establishment of critical limits, monitoring procedures, corrective actions, verification, and record keeping, but may not encompass all elements mandated by FSMA. Focus on preventive controls. Food Safety Plan places a strong emphasis on preventive controls, requiring facilities to implement measures to prevent hazards before they occur, rather than relying solely on reactive measures. HACCP Plan, while also incorporating preventive measures at critical control points, the focus may be more on monitoring and controlling specific hazards identified within the process. Overall, while there may be overlap between a food safety plan and a HACCP plan, especially in terms of hazard analysis and preventive controls, the FSMA's requirements for a food safety plan extend beyond traditional HACCP principles to encompass a more comprehensive approach to food safety management. Great job on completing Chapter 1 lecture. Your commitment to learning and engagement with the material is commendable. Now, don't forget to explore all the resources provided and ensure you complete all quizzes and activities. These additional components will further reinforce your understanding and retention of the key concepts covered in the lecture. Keep up the excellent work.